Okay, the chapter 4, okay, polymers is a new chapter. Previously, we don't have this chapter called polymer, but actually, under this chapter, we previously they put the discussion under the carbon compounds. Actually, not the new things, just they separate it out to a new chapter like this. Okay, so let's see. Under this chapter is polymers, right? Okay, what are we going to discuss under polymers? Okay, so first we are going to define what is polymers. Okay, after that, how to produce the polymers is a polymerization. Okay, there are two types of polymerization to produce the polymers. Okay, then after that, we are going to discuss what? Natural polymers and synthetic polymers. Okay, so natural polymers are like the natural rubbers, natural rubbers, and then synthetic rubbers we are going to discuss. Okay, under synthetic polymers, we are going to example thermoplastics, thermoset, and then elastomer. Okay, so actually this chapter is very quite short now, but it's actually why they want to make a new chapter like this, right? Okay, actually polymers is very useful in our daily life. Okay, and then in university it will be under a new subject also. Polymer. Yeah, it's very popular. Okay, so that's why they put under a new chapter like this put together. Okay, so first, okay, let's discuss. Okay, if your school already completed, okay, let's treat it as the revision. Okay, so first we have to define the polymers correctly. So first, polymers, okay, is a long change of molecule. Okay, long change of molecule made up of a large number of small repeating identical unit called monomers. Okay, monomers. Okay, so monomer is a small identical repeating unit. It repeat many times, sometimes few thousand times repeat, or few 100,000 also possible. Then how to combine the monomer together is undergoes a polymerization. Is a process of joining together the large number of monomers to form a polymer. Okay, so let's see this diagrams. Okay, the small dot is like the monomer, one monomer like this. They are not joining together yet. Okay, you just imagine it has few thousand times, right? So undergoes polymerization, then they'll join together. It forms a bond. Basically, it's a covalent bond. Okay, they'll form a polymer like this. So this is called polymer. Is that okay? And then the addition polymerization, actually we discussed in the chapter 2 already, under polymerization, under alkene. Okay, so far okay on class, the definition. Now, what are the type of polymers based on their source? Okay, first one is a natural one, another one is a synthetic one. Okay, synthetic means man-made, natural means original, okay, occur naturally. So what are the natural polymers? Okay, example, normally found in the plants and animals. Okay, for example, protein, natural polymer. Monomer will be amino acid. Starch is monomer is glucose. Rubber is isoprene. Isoprene is a monomer. Okay. Then how about the synthetic polymer? Okay, let's say polyethylene. Polyethylene, right? Is a ethene. This one we discussed in the carbon compounds that time. Then polypropylene, propene. Then polyvinyl chloride, actually is PVC. If you see this, PVC is what? It's chloroethylene actually. Okay. Then polystyrene is a styrene. Then styrene butadiene rubber, SBR. Styrene and butadiene. Okay. Class, do you know where do you see this or not? Anybody you have seen this SPR? Tire, yes, very good. Oh, yes. During the racing, right? F1 racing, you see this word, right? SPR. Okay, very good. Okay, next, there are two types of here. Okay, thermoplastic, thermoset, and elastomer. Okay, let's see. What are the different characteristics and so on? Okay, let's see one by one. Okay, we look into the thermoplastic first. Okay, thermoplastic. Okay, is a polymer. Let me see here. Okay, let's see this one. Thermoplastic is a linear change without cross links. Okay. How about thermoset? Is a with cross link. With cross links. This one is without cross links. Okay. Can you see the cross link? It cross with let's say this line and this line you cross together. Cross it then with the cross link. So this is thermoset. How about elastomer? Okay, we see later. Okay, now we look into the explanation. Thermoplastic is a polymer that becomes soft when heated. Okay, when heated. Okay, and harden when cold. So it can be many times. Therefore, thermoplastic polymers can be recycled. Recycle. It can be many times. Okay, example like Perspex, PVC. Okay, what else? Like polythene. Polythene also can. Another example. Okay. How about thermoset? Okay, thermoset is a polymer that does not melt when heated. Okay, the polymer will decompose. Okay, instead of melt when heated to high temperature, meaning that it won't melt, it will decompose, means change to another substance. Okay or not? Meaning that once it decomposes, right, it change to other compound already. Unlike this one, it will can be mold again. It just melt only. After it cool down, it will harden back. Okay, it's unlike the thermoplastic. Okay, so it cannot be remolded. So therefore, the thermoset polymers cannot be what? Cannot be recycled. Okay, example: bakelite, resin epoxy, and what? And melamine. Melamine. Okay. Okay. Next, elastomer is a polymer with high elastic property. Okay, so it will return to its original shape after being stretched or compressed. Very elastic, high elasticity. So not easily recycled. Example: silicone rubber, styrene butadiene rubber (SBR), and neoprene. Okay, neoprene is another one. Okay, so these are the three types of polymers with different characteristics. Okay, so thermoplastic, thermoset, and elastomer. Okay, next we look into example. Okay, thermoplastic is under this one. Pails, plastic bags, and bottles are made from what? Or this polythene. Okay, polythene or polyethylene. Packaging materials are made from what? Food packaging. Polystyrene. Okay, the food packaging. But now, they always use can be decomposed one. They reduce the usage of this polystyrene. Okay, package. The electric wire insulation and pipes are made from what? PVC, right? Polyvinyl chloride. Okay, PVC it take from where? It take from P, vinyl, V, and chloride. PVC. Is that okay? So this one is PVC. Any question? Okay. Okay, next we look into the thermoset. Okay, under thermoset, where we can see, okay, like electrical plugs, car bumpers, and handles of iron or cookware are made from what? Are made from backlight. Okay, backlight. Okay, the handle. Okay, adhesive is made from what? Resin epoxy. Okay, like the super glue lah, super glue. Then dinnerware is made from what? Melamine, melamine. These are the example under thermoset. Okay, thermoset. Okay. Then how about elastomer? Medical devices are made from silicone rubber. Okay. Tire are made from what? Okay. That one SPR lah, SPR styrene, butadiene, rubber. Okay, SPR. Okay. Then boots, small boats, and wetsuits are made from what? Neoprene. Okay, neoprene. Okay. So here already mentioned to you. Okay, it's a revision for you if your school already discussed this. Okay. Okay or not, class, so far? All this, no other way. We have to remember it, memorize. Okay, now we look into the comparison of characteristics of thermoplastic and thermoset. Okay, so let's see one by one. Flammability. Okay, flammable or not? Okay, thermoplastic, what do you think, class? Easily flammable or difficult, class? Thermoplastic. This one is very easy, very easy. Okay. This one is difficult. Okay, difficult. But it still can be burned. Still can be burned. Okay. This one is harder a bit to be burned. Okay, but this one is easier. Okay, next, resistant to heat. Just now we mentioned already. This one will be lower resistant. This one is high. Okay. How about this? Hardness. Thermoplastic is hard or not, class? What do you think? Thermoplastic? Thermoset and thermoplastic, which one is harder, class? Thermoset is harder, yes. Okay, so this one is harder. Okay, so this one is soft. Okay, and then how about the melting point for thermoplastic? This one, it can be easily melt, right? Okay, so meaning that this one is lower. Okay, so this one is higher. Okay, I think this one, just how we mentioned already, can be more or not for thermoplastic? Yes, right? Okay, yes, can. This one is cannot. Okay, can we recycle or not? This one? Yes, right? Okay, this one no. This one no. The red no is better. Okay, presence of crosslinks. This one got crossing or not? No, right? Okay, this one yes. Because just now we mentioned here already, this one without, this one with. Okay, so the thermoplastic and thermoset polymers are good what? Good heat and electrical insulator, not easily oxidize, waterproof and oil proof. Okay. these are the similarities. They can insulate. They cannot conduct heat and electrical. They are insulator. Okay, so far okay about these three. Thermoplastic, thermoset, and elastomer. Is that okay? Okay, huh? Now we look into the polymerization. Okay, polymerization. Actually, we discussed this under polymer carbon compounds chapter. Okay, already. Now we discuss again one more time. Okay, just revise back now. Okay, so polymerization, there are two types, right? Just now we mentioned already. Okay, first one we look into the addition polymerization. Okay, what is addition polymerization? It's a reaction that occurs when many monomers which have double covalent bonds between carbon-carbon double bond, okay, join together to forms a long chain of polymers. Okay. So the keywords here will be the monomer, they have the double covalent bond, okay, which is like this. Okay. So this is addition polymerization. Okay, we look into example. This one is a basic one. No? Okay, so you see it has C double bond C. Yeah? Okay, then you see these four will be all are hydrogen, right? Okay, then this N represent how many times it can be large numbers of monomers. So this one is a monomer. Monomer. If N is 1,000 times, meaning that this one you have to repeat 1,000 times. You get what I mean? No? Okay, so undergoes a polymerization. Okay, how are we going to draw the polymers? Okay, so remember, C, the double bond gone. No more double bond. Okay, then after that, the remaining still remains H. Just copy only. Okay, double bond no more. So it forms two new single bond like this. Okay, then we put a big bracket like this. Okay, then times N. Okay, so this one becomes a polymer. Okay, so this polymer actually is polyethylene. Polyethylene. So this N, okay, is a large numbers up to few thousand. Okay, sehingga beberapa ribu lah. Actually, this helping you to repeat for a few thousand times. No need to draw for a few thousand times. Just simplify like this. Okay, any question, class? If you are asked to draw the polymer, any question? Is that okay? Okay, huh? Okay, so this one is a basic one. Okay, later part you will see will be almost the same. Okay, let's say this one, based on what I had discussed with you just now. Okay, what do you think is the polymers for this one? Okay, can you try to draw out? Okay, hands on. Ron, never mind, don't worry. Okay, please draw the polymers for this B. Okay, finish already, class? Okay, now we check, we check. Okay, just now I mentioned, okay, you focus to the double bond, right? Okay, so in your polymers, right, the double bond normal lah. Okay, so it should be this. Okay, then the remaining will be the same. Just copy H. Okay, so the double bond you form two new single bond. Sorry, I copy wrong. So this one shouldn't be H, right? This one should be CH3. Okay, then this one times N. Okay, is that okay? Correct on that, class? Then what is the name for this polymers, class? What is the name? Yes, polypropene. Propene. Huh? The name for the monomer, right? Just add in poly in front. Okay, see? Okay, now this one. I think you should be able to draw it correctly. Yeah. If also accepted polypropylene. Yes. But we normally write the simple one, polypropylene. Polypropylene also correct. Another name for it. Okay, now everybody draw for this chloroethene. Okay, ready? Okay, that's already. Again, we look at this. Okay, see. Okay, then copy only. This one is Cl, right? Okay, then big bracket times N. Okay, now what is this? What is the name? Yeah, anybody know what is the name for this polymers, class? Chloroethene. What is this? Yes. Okay. Actually, we can write polychloroethene is okay, but normally we don't write polychloroethene. We will write polyvinyl chloride. Okay, which is PVC. So you see, if PVC, one of the bond is connected to Cl, is Cl. Others or are H. Okay, will be like this. Okay, now very easy to recognize. One of the bond here is attached to chloride Cl. Okay, so polyvinyl chloride. Okay, okay, now I would like you to try to name, and some of it you need to draw. Okay, the polymers. Okay, they are 1, 2, 3, 4, 5. Okay, so in your SPM syllabus, these are the 5 polymerization equation that always coming out in the exam. Okay. So you try this as an exercise. Give you around 5 minutes. I think should be less than 5 minutes. We can finish this. Okay. Finish already, class? Can we discuss already? Okay, huh? Okay, good. Okay, let's see. Okay, the first one. Okay, polyethylene. Okay, so what is the name for this? I think it should be, you can on your mind. Okay, what is this, class? Maybe I call some names. Okay, Valerie. What is this? The first one. Okay, so this one is ethene. Okay, good. Okay. Then what is the polymer? Already written there, right? Okay, it's polyethylene, right? So this is ethene. So this one is polyethylene or polyethylene. Sometimes you will see polyethylene. Okay. Okay, all correct. Okay. Next, for polypropylene, right? Okay. So what is this? Okay, I would like to ask Tiffany. What is this monomer? Okay, so this is propene. Okay, correct. Then what is this one? Just add in a poly in front. Polypropene. Okay. Cannot, class? Okay. Then next, this one. Ellie, what is this? For this, what is this? The monomer. This one, the polymer, yes, the polymer is polyvinyl chloride. The name lah. Okay. Then how about the monomer? Chloroethene, yes. Chloroethene, yes. Okay, so polyvinyl chloride. Okay, just now we learned already. Okay. Okay, we follow the one. If CL you put here, you just put here. Oh, we follow the one given there. Okay, 10 times n. Okay, class. 10. For this one, Clement, what is this? What is this? It's polystyrene, right? So it forms a polystyrene. Okay, so if the monomer, what is the monomer? Yes, styrene. Okay, then how about the drawing? Okay, actually no need to worry so much. Okay, we just follow the one we learned just now. We just follow only. Okay, C. Okay, then this one H, right? Okay, we just follow H. Okay, this one. Okay, we follow. This is a hexagon, right? Okay, like this. Okay, it has 3 bonds, right? Okay, double bond. 1, 2, 3. Okay. The one this one actually is a benzene. Benzene like this. The double bond actually. 2 lines mean double bond. Okay. So actually it is the same as like this. The double bond actually can be this one, or this one, like this. So that's why normally you will see in Form 6, basically. So we will draw like this, a circle in the medium here. This shows that the double bond actually can be like this or like this. Okay, so we draw a circle. Okay, so this one. We just follow. Is that okay, class? So this is polystyrene, huh? Polystyrene. Okay, any question for this? Okay, huh? Okay, last one. You see, all the hydrogen just now, no more hydrogen, all change to F. Okay, don't worry, we just follow only. Okay, follow F. Okay, so the name you just copy down. This is polytetrafluoroethane, or PPTFE, or simple name will be Teflon. Okay, we just copy down this one as a polymer, the name. Okay, the name. Okay, how about this? How about the monomer? What is the name? Okay, very simple, very easy to see. Tetrafluoroethene. Yes. Okay, so the monomer will be tetrafluoroethene. Okay, so where do we see this type of Teflon? Actually is the non-stick coating for pans or other cookware. Non-stick work for cooking one, or in electrical insulator. So normally we will see the Teflon there, non-stick work. No? Yeah. Is that okay? Tetrafluoroethane. Yeah, Michelle, correct. Okay, class, is that okay? So a lot of the naming for the polymers, right? But as long as you know the concept how to draw the polymers, then should be okay. This one times n. Don't forget this one times n. This one also times n. Okay, class. Still can follow, okay, so our lessons tonight we end here. Okay.